All right, everyone. Today, what we're doing in our lesson is we are talking about the vertex form of a quadratic. I have to specify of a quadratic because we have vertex form of more or less every single function or equation or graph. We could have vertex form of almost everything. So we want to be specific and say that we're dealing with a quadratic, which is a very more or less basic graph. It has a very simple curve pattern to it that we can mimic and recreate when we make a drawing of it. It has symmetry, which makes it even easier to draw. So as long as you know what the right side looks like, we call it like maybe the right branch of it, then we could easily just mimic that on the left and make the left branch. When we graph these from standard form, which we just went over, is y equals ax squared plus bx plus c. It's fully expanded. When we graphed from standard form, we had to use a little formula to figure out the vertex. Then we would plot that. Then we would look at our standard form, and we were able to deduce what the y-intercept was by looking at it. You could even compare it if you think in your head, y equals mx plus b. You should know that a line or a linear equation, the last number, that constant b, is your y-intercept. Standard form, it's the same thing, but it has to be, again, expanded, no parentheses, all open, standard form. Ax squared plus bx plus c. C was the y-intercept. If you had something bigger, ax to the third plus bx squared plus cx plus d, well, d would be your y-intercept, and so on. Then we also took that y-intercept and we reflected it or flipped it over the axis of symmetry, whatever way we had to go, and we created another point, another dot, and then we drew a symmetrical little curve. Vertex form, though. Vertex form gets its name from the fact that the vertex is very, very obvious in the equation. So I'm going to write out the equation of vertex form of a quadratic for us right now. Y equals, or we can use f of x, which means function of x. That means for every input, we get only one output. We don't get more than one, at most one, either one. And we're going to put a out front. That a is actually the same a as in standard form, okay? A, and inside of a parenthesis, you're going to have x minus h squared. And then next to here, we're going to put plus k. Most equations, we always put plus signs and default to positive. So if we are using a minus sign or defaulting to negative for some reason, it must be with a good reason. It's on purpose. So this is something to take note of. Now, here, when you have something in this form, the x, it reminds me of the x in a synthetic division problem where we said that you have to have a 1 in front of it in order to use synthetic. It has to be to the first power, right? Plus or minus a number. So this piece reminds me of that from synthetic division. If it's not set up this way, then it's not in vertex form. All right, what else can we conclude? So from here, if we want to find the vertex, it's very easy. We don't need to do negative b over 2a. There's no b anywhere in this equation. All right, there's no b. The vertex instead is going to be h comma k. So if this says x minus 5, minus 5 is part of the equation is normally minus. So this would just be 5. All right, this is where it gets a little weird for people. That would just be 5. And if this said like plus 7, then that would just be 7. Okay, we'll get to all that. That's going to be a first point that we can find. A second point you can find, still important to find, y-intercept. It's usually pretty easy. I want you guys to think back. Before we did standard form, and we said the y-intercept was just c, or linear equations, y equals mx plus b. B is the y-intercept. We graphed just polynomials. We did all those curves, right? And we did end behavior, we factored them, we found the zeros, we decided if it was linear at that x-intercept, or if it was quadratic at that x-intercept, or if it was cubic at that x-intercept. And there was a way that we said mathematically we could find a y-intercept. Does anybody remember what math you need to do with it? Works on literally every equation, every single function that we're going to encounter, this will work. What is the math you can do calculation wise to figure out what your y-intercept is? Does anybody remember that? How did we calculate the y-intercept? You could even think about like, what is every point on the y-axis, what do they all have in common? What does every point on the y-axis have in common? Think about what's that ordered pair? Or that one? Or this one? Or that? Every point on the y-axis has something in common. Do you want to try Liana?
You said the y equal to 0.
Is it y that equals 0? Y moves things up and down. We're allowed to move up and down. We don't want to move. Yeah, the x. Is that what you just said?
I meant to say that.
Yes, I know you did. So we don't want to move to the right or left. So that x coordinate will stay 0. And then the y coordinate could be whatever it wants. So how do you find a y-intercept? You're going to always have 0 in for your x value. And then you get a y value, of course, for the y coordinate. So in other words, fill 0 in for x, then using, if I didn't think this was important to write, I wouldn't write it, okay? Using PEMDAS, whatever, you gotta watch your order of operations, evaluate. So we're gonna work out what the numbers will be and simplify carefully, just combine like terms to get the y value. Okay, so if you can do the vertex and the y-intercept, third, we can get that mirror point again, and then this time we're going to see if we can use this example and the previous example and come up with a little formula to get that mirror point. All right. So actually what I'm going to do is I'm going to do this one a little differently. So actually, I'll leave it that way. I'm going to give us an example. Okay. So this is the formula. All right. This is what it looks like here. These are the rules. And we're going to do an example. Y equals parentheses x let's do plus, I don't want to go too far over because I won't fit things the way I want. So I'm not gonna 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. 1, 2, 4. Let's do x plus 4, close parentheses, squared, minus 13. All right, that's the example we're going to start with. I need to graph this. So if I wanted to graph it, number one, identify what form it's in. So that is in vertex form. Now that we know it's in vertex form, we're going to find the vertex, which is going to be HK. So it's a little awkward at first, but H we find this way. Careful of this weird minus sign. Remember that minus or negative means opposite. So keep that in mind when you try to take a risk to answer this right now. And then K is for this part here. Who thinks they can tell me where I should plot the vertex, which is again, either the highest or lowest point of a parabola? What coordinate should I plot my vertex at? Also using clues like based on the part of the graph that I drew. I'm predominantly focused on quadrant 3. So where should I go to plot my vertex? Where should I go to plot this vertex? I see 2 hands raised. All right. Let's go. This time you want to try it, Paige. Where should I go to plot the vertex? What do you think?
You should plot it on the y coordinate.
Well, I need a full h, comma, k. I want to know what is the h, what is the k? That's x, that's y, and this is the formula that I'm getting it from. So like, what will be the hk for this example? What will be the h?
K will be negative 13.
Yes, the k is negative 13. So the k, not too crazy. But now the h, do you want to try the h one? Liana, what do you think the h should be?
-4.
Right, actually, -4. So the h is craziness, and it is the opposite of what you would think because the formula has a minus sign and this has a plus sign, so it means opposite. It still reminds me of synthetic division because if you think about it, in synthetic division, do you remember when we wanted to get the box number in that corner, in the top corner, we would set this equal to 0. So we would write like x plus 4 equals 0 and solve for x, -4, -4, and we get x equals -4. So it's very, very similar in that it has to have a 1 in front and to the first power, like synthetic. And then the h is like the box number in synthetic. So, you know, if you want to remember that it's sort of like synthetic in that way, that might be helpful, okay? So now I'm going to plot this point very carefully. Obviously, you know, if you don't have graph paper, you just sketch and do your best. So I'm going to go left 1, 2, 3, 4. So I'm going to accentuate this tick mark and mark it -4 and just make it a little bit more dramatic. I'm only going to focus on labeling the numbers I really, really need. Okay. Then I'm going to go down from there. I'm going to go down this way. I'm just counting here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just so I don't lose track. There's -10, 11, 12. This is -13 right there. And I'm just going to go down this dotted line, invisible dashed line on my paper until I'm down here at -13. I'm going to put a big heavy mark to really indicate my vertex. So that dot, ordered pair, was -4, -13, and it is the vertex right over there. Okay, that's the vertex. Now that we have that plotted, the next point we want to find is the y-intercept, which is 0, a y value. In other words, fill 0 in for x. So we're going to fill 0 in for x. Then using PEMDAS, we're going to evaluate and simplify to get the y value of the so I'm going to number like a number 1 for the vertex. Number 2, we're finding the y-intercept. So if you follow those directions, not many steps, guys, okay? If we follow those directions for the y-intercept, it's going to definitely be 0, something. Take 0, plug it in for x. Here's my equation. Fill in 0 for x. Then use PEMDAS, parentheses, 0 plus 4, get that answer. Exponents, square that number. multiply. If there was something out front for A, right now A is just 1. We would multiply. There's no division this time. Add or subtract. So can anyone tell me, if you could do that in your head, what do we get?
3.
For the Y-intercept, I think I heard Jabari, that was you?
Yeah.
You got 3 because you did 4 squared and you got what number?
16.
Right, and then 16 take away 13, and Jabari got 3. I like it, 0, 3. So that means I go to my origin, I go over 0, so it means I don't move, and I go up 3. 1, 2, 3. I'm going to go right here. I'm going to put a nice heavy mark. All right, I'm going to draw a little arrow and point at that, and I'm going to write 0, 3, and I'm going to write above it Y-intercept. I'm going to color coordinate these the same way I colored the other one, so I'm consistent today. I don't remember what I colored them last video, but there's my Y-intercept, 0, 3. Okay, vertex I did in pink earlier. So vertex is -4, -13, and that's that dot right there. I should color that dot as well. We use this information in my equation to help me find the vertex. Okay. Now, help me out with the mirror point, the reflected point. You have this axis of symmetry, which is a line down the middle to show you where you could fold it in half and get the same thing on both sides. So if I want to make this U shape, I need to plot a mirror point, a reflected point on the other side. So Natalie, you want to try to get that mirror point? That's the origin.
Would it be -8?
Okay, -8.
And then the same +3y.
Good, exactly. So if that's the origin, we're going to go -8. So -4 was here. 5, 6, 7, 8. Here's -8. I'll label that underneath. And then the same y, so up 3. So 1, 2, 3. Put a big heavy dark mark there. So -8, 3. And again, that's my nickname for this point. It's just mirror point, just because helps me remember. Now, Natalie nailed it, okay? Natalie nailed it. The 3 even said same y value, right? So that goes right there, the same y value as the y-intercept. Beautiful. What did Natalie do to get -8? Looking at the rest of this, how does -8 connect, Ella? Where did -8 come from?
Well, if you go from the 4 to the 0, 3, like just going straight in a line, there's
Like this right here?
yeah. You just took that amount and put it on the other side and like
Exactly. So whatever this distance was, she just doubled that number or to get it from the origin or use that same distance. So whatever way we want to describe it. So this was 4 units away, then that's 4 units away as well. So what we could do to get that number here, right? Another way to do it mathematically is this over here is going to be double x of vertex. So if the vertex was -4, then that doubled the -4. And what do we get? -8. And if I flip back for a minute, that's what I was trying to see if we could kind of figure it, but it's a little hard with 1. If we tried it here, look, the x of the vertex was -1. The mirror was -2. So that x of mirror point is double x of the vertex. So whatever negative b over 2a is, you double that. Another way to do it, if you double negative b over 2a, you get what? What do you get if you double negative b over 2a as like a formula? What do we get if we double that? It's something kind of simple. You could get a little formula for it yourself. Go ahead, Manuel, you know?
The negative b will become negative b squared.
If you double something, so if I have something like, so if I had your age and it was over 2 times something, so that means I divided it by 2 and divided it by something else. But then I doubled that number. This 2 cut it in half. So what would happen to the 2 that we cut in half?
Become 1.
Yeah, it goes away. So you'll just get negative b over a. Yeah. So if people like our formula people, you know, you could use that. It's not necessary. So if you double negative b over 2a, which was the x of the vertex, you get negative b over a. So if you wanted to do it that way, you could. Not really totally necessary. Okay. Now, last thing I want to chat about. Well, one of two things. Here, if I wanted to take this vertex form and put it into standard form, we have done things kind of like this. Does anybody know what you would have to do to this to get this to look like standard form? Does anybody think they know? What would I have to do to this equation to make it look like standard form, ax squared plus bx plus c? I'm not sure. I think, did you just raise your hand, Natalie? Or was it up from before? Or do you think you know?
Raised up on if I'm right though.
Okay, well, you could try. That's what school's for. We never know if we're right.
Would you distribute it?
Sort of, yeah. So that's probably a good choice of word. So you kind of like expand everything. So you're going to square this. Now this squaring is where people try to take a shortcut, but you actually have to do an extra step here to square this. You can't just write x squared plus 16. So does anybody remember how we square x plus 4 like that to the second power? Does anybody remember how we square that? Maybe if you do, I don't know, Natalie, if you knew that part. Or Ella, I think you left your hand up from before. I don't know if you know, or if somebody else wants to jump in. Go ahead, Jabari. You think you know what we had to do to square something like this?
Yeah, you're basically going to write the problem twice.
Good. You write the parentheses twice, and then you use what?
Foil.
Good. And then you use FOIL. Nice. So I'm just going to write down 2 examples for you guys to do for homework. This will be the end of this little video. I will add this video to our playlist. So you're going to have the video from standard form, and I'll even put at the end of the standard form video a little card click through to this video. And at the end of this video, when we're all done, we're going to go to factored form. So there will eventually be a click through for that at the end of this. If you kind of understand it, and I want you to use the videos to do your homework, I'm going to give you one of each example. If you understood and you were able to mimic what we did here to do your homework, put thumbs up on the video. If you struggle and you don't understand and you don't think you did it right at all, put a thumbs down on the video, okay? And I track your positive and negative thumbs up, thumbs down, so I know what you need more practice with, okay? So again, thumbs up if you understand and you think you could do it with help, and thumbs down if you are riding the struggle bus, all right? So I hope it was helpful. We're gonna have 2 homework examples, and have a good day.